Okay, you're live.
All right, should I start now?
Yep.
All right. Hello, everyone, and welcome to 971 Assembly, Organization, and some of our best practices. I'm Kai. I'm a senior on 971. Last year, I was a manufacturing lead, and I've worked on design, manufacturing, assembly, all sorts of stuff with the team. As you can see, you can ask questions using the Slido website and the event code Spartan series. All right, so before we begin, really, I'm going to talk about the workflow and organization of assembly. So there's actually a lot that has to happen before we go on to assembling. There's a lot of organization systems that need to be in place, and this just keeps track of parts and makes assembly go really smoothly. So here you can see going from left to right, we have sort of a process that we normally go through. We start with manufacturing, so that's when the parts get made. This is where we're going to pair our parts with drawings. Then it goes on to inspection, where we'll put them in uninspected parts bins, so that way we can inspect them. And then that goes on to kitting, where we take all of those parts that we made, all of the COTS parts, which is consumer off-the-shelf parts, and ordered items, and we're going to organize them by sub-assembly. And then finally, we're going to get to assembling, which we're going to take sub-assemblies, put them together, and then put them together onto the robot. All right, so one of the biggest things in keeping organized is using a parts list. This is super important. It's basically a spreadsheet that puts a number to every single part that you make that's not COTS parts, so like not screws, not nuts, things like that. In this, it's really easy to keep track of quality and material type, as well as keep track as where the part is in the process of getting manufactured and assembled. So as you can see here in the picture, there's a bunch of part numbers and part names, and then you can see it's grouped kind of in colors. So we have red, which is like drawings, and then we have orange, which is CAM, which is preparing for manufacturing as well as manufacturing. Then we have inspecting. Then we also have other information, such as the stock type in the machine that's used to make that. And then the way we like to mark parts is one by highlighting, because it makes it look really, it's really easy to go through the sheet and like figure out what parts need to be made, as well as you sign it off with your initials. And that way, if there's ever a question, it's really easy to go back to that person and ask them what happened. All right, next up is drawings and inspecting. So a drawing is basically a printout, as you can see in the picture, that shows what the part should measure out to be. We use this to keep organized. So we'll often put a part and its accompanying drawing in a plastic bag together. This keeps them from getting separated, makes it easier to keep track of them. And then after manufacturing, you're going to want to make sure to inspect the part. So this prevents out of spec parts from getting on the robot, because you don't want a piece to be too big or too small or be a bit wrong, and then it's on the robot and then it's really hard to fix. And then this also ensures that there's time to remake the part if it's wrong, because if you put it on the robot and you only realize that it's wrong once you're at competition, you can't really remake the part in time. So drawings and inspections, super important. Next up is kitting. So kitting is basically a container of parts that we organize by assembly. So this contains every single part that you need to make an assembly, all of them. And this basically puts everything together, which makes assembly go a lot smoother, because that way you aren't looking for like a certain type of screw for 30 minutes, and then it just adds huge amounts of time to your assembly process. So putting everything together in a box while you're manufacturing all the parts, while you're receiving all the parts, makes assembly at the end go a lot smoother. All right, next up, we're gonna look at some best practices and techniques that we found to follow while assembling. So the first one isn't quite assembling, but deburring. Deburring is super, super important. The main thing it helps with is safety. It ensures that there's no sharp edges on or inside the robot. And this is super important because if you're at a competition or something hectic is happening, you're assembling the robot really quickly, and you're like getting your hands in, trying to like put a screw in deep inside the robot or something like that. You don't want to cut your fingers and get blood all over inside the robot. That would really suck. It's kind of a big problem. So no sharp edges in the robot. We ensure this by deburring the holes. Now you don't want to deburr the part. you don't want to deburr everything. So the precise holes, for example, bearings, you don't want to deburr because if you deburr it too much, you take off too much material, then it won't fit anymore, and then the bearing can just slide in and out. It messes up with the fit. Um, Once you're done deburring, you want to make sure to clean the part. And this ensures that all the scrapings that you've scraped off, and like if you use sandpaper, all of the aluminum dust or whatever doesn't stay with the part. Make sure it all gets cleaned. And that way you have a good looking robot and less likelihood of things going wrong. All right, one big thing to make sure you never do, don't use a hammer unless like you're actually supposed to use a hammer. And that's super rare. So there's many problems with using a hammer to assemble anything. The main problem is that if it takes a hammer to put something together, it's going to take more than a hammer to take it apart. So this is a big problem because a hammer is, a pretty big thing, and if it takes a hammer to put it together and you can't take it apart with a hammer, it's really, really difficult to take that assembly apart if you ever have to repair it. Also, hammering shafts, for example, can mushroom the ends, and this makes it really hard to remove the shaft, might not remove at all, which could be a really big problem if you ever have to repair something. There's a bunch of solutions. As I said, you should almost never have to use a hammer. Whenever you feel like you need to use a hammer, it's normally because parts are interfering. So what you want to do is go through all the parts that aren't fitting together and figure out what's wrong and fix that, and then it should all go together really nice and smooth. Also, you want to use the right tool. For example, bearings are pressed in a plate, and for that, you want to use an arbor press. You don't want to use a hammer. All right, moving on to the next thing. We want to keep bolts from vibrating loose. This is really big. 971, we learned our own lesson with this. A screw fell out in the drivetrain in 2016 competition, and we basically lost the game because of that. So that was really sad. We learned our lesson. We make sure everything is super tight on the robot now. Now, there's multiple different ways of keeping screws and things like that attached to your robot and keep them from vibrating loose. One of the super popular ways is using Loctite. Loctite is a type of glue. It comes in a liquid form and a sort of paste form. You can see in the top two pictures. And because it's a glue, it means it needs to cure. It needs to have some cure time. So that means once you screw something in, you have to wait a little bit before using it. But it's not that long, so it's not big of a problem. Also, with Loctite, if you ever take it out, because it's a glue, you have to reapply the Loctite before putting the screw back together. Because if you take it apart and put it back in, it's not going to have that locking capability. As you can see in the other bullet points, there's different types of Loctite that are used for different purposes. Blue Loctite is general purpose for metal. And then you have plastic safe. This will not destroy plastic that a bolt goes through. This is really important because if you use normal blue Loctite on a screw that goes through a piece of plastic, it could disintegrate the plastic and possibly ruin your mechanism. And then there's also green Loctite. We almost rarely use this. It creates a super, super permanent bond. We don't use on screws because it makes it impossible to take out as it is a permanent bond. Some other solutions for keeping screws from vibrating loose include nylon lock nuts and nylon patch screws. We don't really use nylon patch screws because we found them to not work super, super well, and they're pretty expensive. But nylon lock nuts work super well. Basically, how it works is the nylon adds friction that keeps the whole screw from vibrating and therefore coming loose. It's really cool because it can be reused, and you don't have to tighten the screw all the way down for it to have its thread locking ability. All right, next up, we're going to talk about Allen heads and wrenches for Allens. So the Allen head bolts are preferred for robotics as they don't slip or strip easily and are pretty common in sheep. And then the wrenches for these Allen screws come in different varieties, different types. And these types basically balance access and flexibility with torque, or how much force you can put into the screw to tighten it down. So the main thing between this is a ball end versus a flat end Allen wrench. So a ball end has a ball at the end. You can see it in the top right picture. And basically allows you to approach the screw from multiple angles. This is really cool for hard to reach screws that are like deep inside the robot. Maybe you can't come at it straight on. And then a flat end is used for higher torque because it doesn't strip as easily. A ball end has less surface that's contacting on, and therefore it can slip pretty easily stripping. So what's often done is you use a ball end to start because you get better access, you can go really quickly, and then use a flat end to finish it. And that way you can apply a lot of torque at the end and make sure your screws nice and tight. Then you have different sort of handles. You have a T handle, which you can see on the bottom. It has good grip. You can get a lot of torque. You have a driver style. That's the middle picture. It's good for confined spaces because it doesn't have this big T that blocks your way. And then you also have an L key, which is pretty cool because it has lots of versatility, as it has a ball end on one side and a flat end on the other. So it's kind of a two-in-one. It also is pretty small. You can fit in a lot of tight spaces. Moving on, fiber washers and when to use them. So fiber washers are like thin spacers. They come in 1/32 or 1/64 thicknesses, and then different sizes for different shaft sizes. They're often used to space things off of bearings and other things on shafts. Bearings especially because bearings, you're only supposed to touch the inner race, because if you touch the outer race, then it doesn't have its spinning ability because you're kind of basically contacting the entire bearing, and then it can't spin. It's also used to take up play on shafting. So if you have a lot of things on your shaft and they're kind of moving around, they don't have really good tolerance, they can put a few fiber washers on, it'll take out the slack so it doesn't slip back and forth super easily. All right. On the topic of shafts, snap rings. Snap rings are basically a ring of metal that attaches to the end of a shaft and it holds it in place, so it keeps it from coming out of bearings mostly. Other things as well. They have a special tool called a snap ring plier that's used to install them. They come in from two different angles essentially, straight on or like at a right angle to the plate, and that's just for different access. Yeah. When you're installing these things, you want to make sure you're wearing safety glasses. That's super important. As they are essentially small spring metal things that can go flying if they slip out of the pliers or anything like that. So it's super important that you wear safety glasses. You don't want to get injured. Also, you don't want to ever use overstretched snap rings because if it doesn't hold snug, then it has a high likelihood of coming off. And you don't want the snap ring to come off because then the shaft can come out too. All right, next up, we're going to talk a little bit about pop rivets and when to use them. So pop rivets are pretty cool as they are a quick and strong way to join two plates. We on 971 use 3/16 or 1/8 inch diameter rivets with steel mandrels. We just found those to be the strongest for their size and all that. The steel mandrels keep it from getting ripped apart too easily. So when you choose a rivet, you want to make sure that its grip range covers the materials that are being put together. So as you can see in the top picture, the rivets, they're all the same diameter, but they have different lengths. So this corresponds to different thicknesses of material that they can hold together. So here you can see an example. If you take an 090 plate and an 062, if you add it up together, that's your material thickness. You're going to get 0.15. And so that means you want to use a rivet that has a, in this case, 1/8 inch to 3/16 grip range. And that just ensures that the rivet is doing its job. It's a bit better to go over than under. If you go under, then the rivet isn't going to be able to mushroom as much, and then it won't hold your parts together. So if you have to go over, but try and stay in the grip range. That's what it's intended for. When you're pulling rivets, that's the act of like using the gun or rivet thing to pull the mandrel and mushroom the end, as you can see in the bottom picture. It's called pulling a rivet. You want to make sure to be as straight as possible. This keeps things from breaking off at weird angles. Make sure everything is nice and tight. We found that the pneumatic rivet gun works the best as it pulls all the rivets like tightly, consistently. Everything works better with it, but it's a bit big. That's the rivet gun in the bottom in the blue. So it pulls it better, but it's a bit big and it's a bit expensive. So it's okay to use a handheld if you don't have one, or if you need to get in the tight space. That's the one of the red handles. And also an important thing to note is that you want to use rivet washers to spread the load for brittle materials. So when you're pulling a rivet, it exerts a lot of force right in a small point where the materials come together. Because there's already a hole, brittle materials will crack and splinter and all that sort of stuff um, if you use rivets. So for plastics and woods, you want to make sure to use washers to spread the load and prevent the material from splitting. Okay. Um, how to properly install bearings. Bearings wear out, and for this reason, we only use new bearings on seasoned robots. Um, that's just something we do. It ensures that all of the bearings on the robot are good and high quality and haven't worn out yet. When you are assembling a bearing, you want to make sure to double check CAD to determine which way it goes. Because often in an assembly, um, often these bearings have flanges. The flanges make it so there is a correct way to install them, because not all plates are mirror images of themselves. You want to make sure to put it in the right way, because if you have to press a bearing out again and then put it back in the same hole, it can mess up a lot of things. It wastes time, it can ruin the bearing, and it can also ruin the fit, so it isn't as tight of a fit. When you are installing bearings into plates, you want to make sure to only press on the outer race, not the inner race, as the inner race, if you only press on the inner race, it's going to crush the balls in the middle and like put contact in between them, and that's going to keep the bearing from turning smoothly. And that basically ruins the purpose of a bearing. So you want to make sure to only press on the outer race when you're pressing in a bearing or taking a bearing out for that matter. A little trick that we found, if a shaft does not fit, but it should, you can carefully sand down the shaft a little bit. It works pretty well to making sure a shaft fits in a bearing. You don't want to sand down a bearing because you lose eccentricity. So that's how round and perfectly in the center it is. And it's also hardened steel, so it's pretty hard to sand down compared to a normal aluminum shaft. Some problems with bearings include if it's not pressed flush or is crooked. So that means when you're pressing it into a plate, it's down on one side, but it's still raised a little bit on the other. And basically, the bearing is crooked in the plate. And this makes it so the hole isn't super straight or perpendicular to the plate. So you can have problems with things lining up if that happens. Also, if the inner race is pressed, as we said before, then you're going to have problems with the bearing spinning smoothly. All right, our final slide here. Be aware of cross-threading tapped holes. So aluminum is a very soft metal, so you always want to be careful when threading holes into tapped aluminum parts. It's super easy to wreck a hole that is in a part that is really hard to replace. So if you're trying to screw something into a robot and the plate is a plate you machined out of aluminum, if you come in at it and you strip the threads, it can be really bad because you can't really use that hole anymore, and it's really hard to replace that plate. Cross-threading happens when a bolt is screwed in at an angle or is forced when the threads don't line up. So this most often occurs when bolts are put in when the holes don't quite line up, because that forces it to come in at a weird angle, or when you have poor access and need to use a ball Allen wrench, because that means it will come in at an angle also. And yeah, that's it. Thank you for watching, and let me know if you have any questions using the Slido website link.
We have a couple questions on Slido already.
All right.
The first one is, what's the most effective way to teach new members assembly?
Well, I think the most effective way is to get someone that already knows how to do it to like watch over and give examples of how to properly install bearings, for example, when you're assembling something. So like it involves like someone that knows what they're doing to not just do it by themselves, but also involve some new students and show them how it's done.
What's the most challenging part of building a 971 robot?
The most challenging part, a 971 robot. Well, our robots can be pretty complicated. So there's a lot of different parts that need to get organized and put together. We also order a lot of parts that are like specialty and super specific for the task. So just making sure we have all of those stuff This is where kitting comes into a super big importance. You want to make sure that all of your parts are together before you start assembling, just to make sure you have everything. That's a good question. Yeah.
How does 971 maintain lab organization?
Lab organization is really difficult because our lab is pretty small. We always work hard to keep everything organized. Um, I think one of the biggest things is making sure that everything has a place to belong, right? So if, after a part has been machined or whatever, you want to make sure that there is a spot for it to go. You want to make sure there's a bin for it to go. You want to make sure after it's been inspected, it has a bin to go to be kitted. You want to make sure all your wrenches, all your hammers, don't use hammers, all your snapping pliers, all your screwdrivers, all that sort of stuff has its own spot, and that you make sure you clean up regularly.
What are some best practices for maintaining lab safety?
Um, so for us, we're super big on lab safety. If you're in the lab, you have to wear safety glasses. There's no real questions. You have to wear safety glasses. Um, Also, everyone that's using a tool has to be trained on how to use that tool. You can't just come up to a tool you don't know and pretend you know how to do it. You have to get trained on the tool before you can use it. Those are the two main things.
What's your favorite part of the assembly process?
My favorite part is putting it all together and seeing the part made because you know you see it before in CAD, but it's something different to see it like in person and see it like working, everything spinning nicely together.
Okay, that's all the questions we have for now.
All right.
So if you have any more questions, drop them in the Slido. Do you have a distinct separation between assembly and machining?
A distinct separation between assembly and machining. Well, it's all sort of a process, and if you break them like specifically into different like sections, there's like a bit that comes in between. So you have like machining, and then from there you have like inspection, which I guess you could kind of call machining. Um, but then you also have like all the preparation for assembly, like kitting, before assembly actually happens. So I guess you could split it off into like two halves, but it kind of intermingles into itself.
Was there a trial and error to get to this workflow process? Were there other setups that tried and were rejected?
Um, I don't know. The team has been around for a while, and I haven't been on since the beginning, obviously. Um, but I think we've just tried things and seen what works and gone with what works.
Do you have any sort of a plan on how to teach new members assembly virtually, since we probably won't be in the lab for a while?
That's really difficult. Um, I would say it's really difficult to teach a hands-on thing. Like you can't really teach someone how to use a tool correctly, how to use like a saw like correctly, and expect them to know how in person without actually guiding them through the process physically while being there. And I think the same sort of applies to assembly. Now, assembly isn't like super hard, but making sure you do things right is really important. So I think as long as you ensure that the people that know what they're doing know to help new students when the time comes to actually be there and physically assemble your robot, um, I think that will be really big and really important. Yeah, so making sure that advanced people are helping the new students figure out what to do.
Yeah. Is McMaster the best place to get fiber washers? And if not, where does 971 get theirs?
Oh, we get almost everything from McMaster, and I think we get fiber washers from them too.
About how large is our assembly/mechanical team?
How large? It's hard to say. Like we have a lot of members that come in often, and we have some members that don't come in quite as often. We don't have a super big count. Assembly is one of those things that if you don't come as often, it's a lot easier to help with than say design is, where you have to be there like almost every day of the week. Um, So I'd say on 971, there's like 20 or 30 people that participate on assembly for a robot in the year.
We don't have any more questions right now. What was your favorite robot to assemble or to help assemble?
Hmm. Last year's robot was pretty difficult because it was really, really small. So there's a lot of things in tight spaces. That was difficult. Um, Assembling, I think actually 2017, assembling was super fun. The intake arms were really cool. They had a lot of parts to go to assemble together. And then also assembling and attaching the arm was really cool into the gearbox and putting the custom like end caps into the carbon fiber arms.
That's all we have. Maybe we can stick around for another few more minutes and see if
Sure,
people have any more questions.
sounds good.
Doesn't seem like we have any more questions coming in.
All right. Well,
Melissa,
thank
are you
you.
good if we just sign off?
Yeah.
Yep, go for it.
Okay.
Just read the message I put in the chat.
Yeah, thank you so much to everyone who tuned in today. And be sure to come back and check out our talks for the rest of the week, including tomorrow's panel with the drive team that I will be moderating, which should be super fun.